a cool question. They're asking us to find the area of the largest rectangle that fits into a triangle with a side of x is equal to 0, y is equal to 0, and then the equation of this line. So to kind of get a visual of this, what I would do is I would solve this equation for y, because we're talking about a line here. So if I solve for y, what I'm going to get, and again, I'm skipping some steps here, but I would subtract the x over 4, and then I would multiply by 6, and you will get 6 minus 3x over 2. So taking this equation, solving for y, you get 6 minus 3x over 2. And that gives you a little bit of an idea of what our picture looks like, because our line is going to be up 1, 2, 3, 4, 5, 6. And then we're going to go down 3, 1, 2, 3, and to the right 2. Okay, and then down 3, 1, 2, 3, and to the right 2. So this is our line. And they're asking us to find the largest rectangle that fits into this little triangle that has a side of x is equal to 0, y is equal to 0, and then this line is the third side of the triangle. So what you're trying to do is you're trying to figure out where is this rectangle that's going to maximize this area of the rectangle. So we are trying to maximize the area of the rectangle subject to these constraints that x is equal to 0, y is equal to 0, and this line. And when you take this line and solve for y, you get 6 minus 3x over 2. Okay, so we want the area of the rectangle, so we're going to write out the equation of our rectangle as length times width. Now, because you are oriented to the Cartesian coordinate system, you have to think about what the length of this rectangle would be and what the width of this rectangle would be. So remember that this point right here is x comma y. So the horizontal distance is going to be our x. The vertical distance is going to be our y. So this little rectangle is going to have x times y for its area. So we are trying to maximize the area, which is x times y, subject to, now this constraint of x is equal to 0, y is equal to 0, that is embodied in the picture here. But what's really relevant for us is this line 6 minus 3x over 2, because that's going to determine this point right here, this x comma y point, that will maximize the area. Okay, so we're trying to maximize x times y subject to this y equation. Now, as you notice in your objective function here, you have two unknowns. So what we're going to do is we're going to plug in this solved constraint for the unknown of y. So that will give us the area function as x times our y, which is 6 minus 3x over 2. Now, you'll notice at this point that your objective function is in one variable, and so that tells you that you are ready to take the derivative, set it equal to 0, or does not exist. And remember, the whole process, once you have it in one variable, all you're really doing here is the first derivative test. Okay? All right, or the second derivative test. So what we're going to do is we're going to take our derivative. Before we take the derivative, though, so we don't have to use the product rule, I would distribute the x here, so you get 6x minus 3x squared over 2. And then once I have that as two terms, I would take its derivative and get 6 minus, bringing down the 2, I would get 6x over 2. So that gives us 6 minus 3x for our derivative. So we would set that equal to 0, and in solving, I would get 3x is equal to 6, divide by 3, I get x is equal to 2. Now, of course, we want to verify that this truly does maximize the area. So to verify, you can either use the first derivative test or the second derivative test. In this case, just for practice, I'm going to use the second derivative test. So I will take the second derivative of the second derivative of this function, and if you look here, your 6 is going to go to 0, the negative 3x becomes a negative. So here the second derivative test is super easy, because when you get that negative, that tells you that you're concave down, and if you're concave down, that means you must have a max at x is equal to 2. Okay, so we have verified that x is equal to 2 is going to give us our max. Now, we need to actually find the area. I believe in this question, let's see, they say find the area of the largest rectangle. So what we're going to do is we're going to go back to our constraint. And our constraint was y is equal to 6 minus 3x over 2. And we're going to use that solved constraint to find the y coordinate. So we'll have 6 minus 3. The x value we'll plug in as 2 over 2. So these 2's cancel, and you get y is equal to 3. So what we are finding here is that the dimensions of our rectangle were going to be x times y. The dimension will be 2 by 3. Now, they didn't ask for the dimensions. They said, what is the largest area? So our area was x times y. So we will have 2 times 3, giving us that our area is 6. So the area of the largest rectangle is going to be 6 units squared.